Okay, so today we're going to talk about exponent rules and simplifying expressions with these rules. So the first rule that we want to look at is the product rule. So the product rule is a to the x times a to the y equals a to the x plus y. So let's say you have 2 to the third times 2 to the fourth. You want to add 3 and 4, and so then your final answer will be 2 to the 7th. Okay, now let's look at the quotient rule. So the quotient rule is a to the x divided by a to the y is going to be equal to a to the x minus y. So let's say you have 3 to the 7th divided by 3 to the 5th. 7 minus 5 equals 2, and so then you're left with 3 squared. Now, let's look at the power rule. You have a to the x to the y, which will then equal a to the x times y. If you have 4 squared and then you want to raise that to the third power, you're going to multiply 2 times 3, which equals 6, and then you're left with 4 to the 6th power.
Next, we have the power of a product rule. So in this, you have a times b to the x, which equals a to the x, b to the x. So let's say we have 2xy all raised to the third. That would equal 2 to the third, which is 8, times x to the third, y to the third. Next, we have power of a fraction rule. In this, you would have a over b and all of that raised to the x, which equals a to the x over b to the x. So let's say you have x squared over 2y to the third, all raised to the fourth power. You would have x to the 8th over 2 to the 4th, which is 16, times y to the 12th. The zero exponent rule basically states that anything raised to the 0th power will always equal 1.
The negative exponent rule says that a to the negative x will equal 1 over a to the x. If you have 5 to the negative second power, that's going to equal 1 over 5 squared, which then equals 1 over 25.
The fractional exponent rule is when you have a to the x over y. This would equal y root of a to the x. So let's say we had 25 raised to 1 over 2. This would equal the square root of 25, which is equal to 5.
So let's look at question number 1. We want to subtract the denominators from the numerators. So 5 minus 1 equals 4, and 6 minus 2 also equals 4. So this would be the answer to question number 1.
Now looking at problem 2, it may seem a little bit complicated, but if you look closer, it is all raised to the power 0, therefore it equals 1.
Now we're going to solve question number 3 using the negative exponent rule. So the answer will then be 1 over 7 squared.
In problem 4, we will be using the fractional exponent rule. So we will have cube root of 4 squared times x squared. Now 4 squared is 16, which is 2 to the 4th power, which means we can take out a 2 from the root, leaving 2 times x squared.
So similar to question 4, we're going to use the fractional exponent rule for question 5. But notice that x is the only one that's raised to the 2/3 power. So 4 will be outside.
Looking at problem 6, I'm going to start by simplifying the inside expression. So 5 over 20 is equal to 1/4. And then using the quotient rule, we can take x to the third over x and subtract the exponents, leaving x squared. Again, we can use the quotient rule for the y to the 5th over y, leaving y to the 4th. And all of that will be raised to the 4th power. This leaves 1 to the 4th, which is still 1, times x to the 8th times y to the 16th over 4 to the 4th power, which is 256.
For 7, we're going to use the negative exponent rule because we don't want anything to be raised to the negative power. So it's going to be x to the 9th over x to the 4th. And then we're going to use the quotient rule and to simplify that. So 9 minus 4 equals 5. And so our final answer will be x to the 5th.
Well, that has been our video on how to simplify expressions using exponent rules. Thank you for watching, or at least pretending to. Have a great day.